All right, good afternoon. This is the last section of the unit here. So we have a test next week. And this is very much like what we did in the previous section. We want to be able to determine the solution set of a rational inequality. And again, that's really just begging the question, where is the function greater than 0, which means where f of x is positive, or where is the function less than 0, which really just means where f of x is negative. So this really becomes a question of, is it positive or is it negative? And that's sort of what we have to look for. Now, graphically, we have a nice little example, and again, when in doubt, graph it out. The function is positive anytime it is above the horizontal axis. When it's above that x-axis, our function is positive, and if it's below, it's negative. So it's pretty easy to see. This graph has a vertical asymptote right here at x equals 1, 2, negative 3. There's a vertical asymptote right there. Where's the other vertical asymptote? 2, yes. There's another vertical asymptote right here at 2. And there's also a couple of zeros here. Here at negative 1 and 1, 2, 3, 4. So this graph and at any of these places at the vertical asymptotes or the zeros, this is where the function changes from negative to positive. So when we are looking at rational fractional functions, we have to pay attention to the zeros of the numerator and the vertical asymptotes from the denominator. So we just have to take care of all of those things, and that's going to help us figure out where it's positive or negative. Okay, so looking at this function, name all the intervals for which our function is greater than 0, which means positive. What are the intervals where this graph is positive? Positive means above the axis. Here, right here? Here our function is above the axis. Yeah, negative infinity all the way to? Yeah, negative 3 right here. So from negative infinity to negative 3, so negative infinity to negative 3, our function is above the axis. Where else is our function above the axis?
Negative 1 to...
Yeah, negative 1. There it goes. It's positive in this region, positive up there. From negative 1 to 2. Yeah, right there at 2. So negative 1 to 2 is positive. And where else is it positive? 4, yes, 4 and onward to the right. So 4 to infinity, it's also above the axis. So the others would be less than 0, where is it negative? And that would be where it is underneath. Yeah, negative 3 to negative 1 is this little section right here. So negative 3 to negative 1. Yeah, and then 2 to 4, this little section in between, from 2 to 4. And again, when we're talking about the intervals, we care only about the interval on the x-axis. And that's really the important part. That's our independent variable, the variable that determines everything. So notice here that a rational function switches signs at both zeros and its vertical asymptotes. So that's what we're going to start out doing today. We are going to make sure that we're set equal to 0. We're going to find the zeros of the numerator and the denominator, and then do a sign chart. and write down the intervals accordingly. So solve each inequality, use the number line to test intervals. I'm going to mark it kind of how you'll see it in Delta Math. So what we want to do is find the zeros of the numerator. So I would set x plus 5 equal to 0. What does x become? X equals negative 5. That's a 0. And I'm going to set the denominator equal to 0. And x equals negative 2. That is a vertical asymptote. So whatever comes from the denominator is our vertical asymptote. So I'm going to draw that. At negative 2, I have a vertical asymptote. I want to keep them straight because this is going to be important when we're graphing. And then at negative 5, we have a 0. That is where our graph crosses the axis right there at negative 5. What we're going to do is we're going to test in between those. I'm going to go ahead, just like Delta Math, it's going to put a little dotted line through that, but that one's actually a 0 there. We want to know, where is this rational fractional function greater than 0? What does that mean? We want positives. Okay, we want to know, where is it positive? All we need to do is plug in some points. So I'm going to start by plugging in a point to the left of negative 5. Give me a number that's to the left. Negative, I'm going to just use negative 8 because right there I was staring at it too. If I plug negative 8 in, I would have negative 8 plus 5 over negative 8 plus 2. But again, all I really care about is whether I'm getting a positive or negative result. Do I care about the actual numbers? I don't really care. What do we get on top? A negative. And what do we get on bottom? A negative. And what is negative divided by negative? A positive result. Okay. What can we plug in between negative 5 and negative 2? Negative 3. Okay. So once again, I'm going to go up here and just plug in negative 3 plus 5, negative 3 plus 2. What is negative 3 plus 5? What's the positive 2? And then on the bottom? Negative 1. And again, I really don't care about the value. I just care if it's positive or negative. What is positive divided by negative? Negative result. So in the middle, we're getting a negative result. And then, I think I'm going to test 0 on the right side here. So 0 plus 5 over 0 plus 2. That's going to give me positive over positive, which gives me a positive result. So now we just need to write down our interval, which was, where is it positive? Negative infinity to negative 5. So negative infinity to negative 5. Now, do I use a bracket or a parenthesis at the 5? Parenthesis, yeah, because we just want to be greater than 0, not including 0. All right, and then where else do we need to go? Yes, negative 2 to infinity. There, I'm just going to use brackets. There we go. To infinity. So negative 2 to infinity. And there is our positive region. Okay? Let's look at number 2. Again, I think I see something I can double bubble here, so I'm going to go ahead and just double bubble that. How does x squared minus 5x minus 6 double bubble? X, and then negative 6 and positive 1. Good. Now, I'm going to set everything equal to 0. So I'm going to set my numerator equal to 0. That gives me x equals 0. That is a 0. And then I set the denominator. Each bubble gets set equal to 0. So what do we get for those solutions? And those are vertical asymptotes. Since they came from the denominator, they give us the vertical asymptote. So I'm going to mark those on my picture here. I have a vertical asymptote at 6, so that's a vertical asymptote. At negative 1, I have a vertical asymptote. And then at 0, I have a 0. Ooh, that's very close together. Now, how many sections do I have to test? 4, actually. This is a sneaky one right here. Yeah, between -1 and 0 is a whole nother section I have to test. Let's see. I'm going to plug in something like -6. I'm going to try -6. And -6 would be a negative on top. And then in the denominator, I just want to look at those bubbles. If I plug in -6, -6 minus 6, that gives me a -12. And then -6 plus 1 gives me -5. So negative times negative turns positive here, yeah? Yeah, so negative divided by positive turns out to be a negative result there for that one. Again, we're multiplying the bubbles in the denominator. So lots of negatives there. Odd number of negatives turns out to be negative. We're good there? All right, what's the number I can plug in between 0 and -1? Yeah, -0.5. So we're going to try thinking about that. -0.5, a half. All right, I'm going to plug that in up here. So we get, again, a negative in the numerator. And then in the denominator, I would have another -6.5. And then, this would be -0.5 plus 1 would be a positive result there. All right. So let's see. Negative times positive gives me a negative in the denominator. And negative divided by negative is positive. So right in between -1 and 0, I get a positive section. All right, let's see. I guess I'll test 3 here in the middle bit here. Let's see. That's going to be a positive on top. When I plug it in, 3 minus 6, that gives me a negative. And 3 plus 1 gives me a positive. What's my end result here? A negative. We got an odd number of negatives, so we're going to be negative. And I think I'll plug in the 8 here on the last side. If I plug in an 8, that's a positive on top. And in the denominator, I would have a positive bubble, and I would have another positive bubble, which gives me a positive result overall. Is that making sense to you guys? Yeah. Figuring out positives and negatives? Yeah? Okay. So the question was asking, where is the rational fractional function less than 0? What are we looking for? Negative. Where is it negative? All right, where is it negative? Negative infinity to -1. Beautiful. Negative infinity to -1. Union? 0 to 6. And we're not including the 0 or the 6. Okay. So 0 to 6. So there's my interval that is negative. All right, questions so far? Okay. We're going to do 2 more. And again, I changed them. So this is the kind you're going to see on Delta Math. So we have x plus 1 quantity cubed over 2x plus 8 quantity to the 4th power. And we want to know, where is it greater than or equal to 0? All right, so once again, I'm just going to start by finding the zeros of the numerator and denominator. So what are our solutions for x? -1, that's a 0 because it came from the top. And then what do we get in the bottom? -4. X equals -4. That's a vertical asymptote there because it came from the denominator. All right, so I'm going to just do a little number line. -4, -1. I don't like her number line. It's just too small. I would rather make my own with just my 2 little things that I'm interested in. -4 is a vertical asymptote, and 1 is a 0. So I'm going to put a nice big dot there because it equals 0 there. But Delta Math will put in these little boundary zones, the little vertical lines there. All right, so I want to pick a number to the left of -4. What's to the left of -4? Sure, -5. All right, so -5. If I plug in -5, then I would have a negative number being cubed. And in the denominator, I would have a negative number to the 4th power. Are you with me? All right? And then what is a negative number cubed? Still a negative. And then a negative number to the 4th power? Positive. Good. And so this result ends up being negative. Beautiful. Okay. What can we use between -4 and -1? -2. All right, so -2. We get a negative cubed, which is still going to be a negative. And -2 would be -4 plus 8. That'd be positive. So we get, again, another negative. So these ones you do have to be a little careful because they don't switch every time. And then what's to the right of -1? 0. All right, with a 0, we get a positive value on top and a positive value on the bottom, which means positive overall. All right. And we are looking for what? Where are, yes, positive or equal to 0. So let's see, positive, all right, right here at -1, are we equal to 0? Yes. At -1, it is 0. Yeah, so that's going to be a bracket, and we want to know where is it greater than, so that would be everything to the right. So bracket -1 all the way to positive infinity for that interval. Any questions on that one? All right, let's look at one more and then we're done. Let's make this one also equal to 0, just so we've done one of each, sort of. All right, so we have x cubed over x minus 7 quantity to the 4th power is greater than or equal to 0. 7 is at my numerator equal to 0. That gives me x equals 0 is a 0 of the graph. And what do we get in the denominator? X equals 7, which would be a vertical asymptote. So I'm going to make my little number line. Now, 0 is actually a 0, so I'm going to make myself a big point there because it actually is equal to 0. And then at 7, it's a vertical asymptote. All right, so I'm going to pick a value. I'm going to just pick like -10. I could use -1,000. It wouldn't matter. So here, if I take a negative and I cube it, what do I get? A negative. And here, -10 and a -7 makes -17. To the 4th power, what do we get? Positive. And overall, that's going to be a negative result. Good. Isn't that easy? Like, it's so easy once you get used to it. All right, I'm between 0 and 7. I'm going to plug in a 5. 5 cubed is a positive result. And here, I get a negative to the 4th power, which is always positive. So that's going to give me a positive result. And then a number to the right of 7, I'm going to use 10. I'm going to get a positive on top and a positive on bottom, which gives me a positive result there. All right, now that we've got our positives and negatives, we are trying to figure out where our function is. Yeah, positive and 0 equal to 0. Positive or equal to 0, which is in these regions here. So what do we do at 0? It's equal, so that's a bracket there. All right. What do we have to do at 7? We got to take it out. We got to use the parenthesis because we're not allowed to equal it. So any of those, be very, very careful. So this goes from 0 all the way to 7, parenthesis, union 7 to infinity. So are we allowed to equal 7? If I plug in a 7, I would get 7 minus 7, which is 0. I would get as undefined. I'd get a 0 in the denominator. So we have to remove the 7 because it's a vertical asymptote. All right. Do you have questions for me?
I have one.
It's the delta math.